Hello and welcome to this video about building your own sort algorithm visualizer. My name is Mike Duffy and this is the second of 3 videos about creating your own. This is version 2, improvements. Okay, what are we building? We are building some improvements to the original version of this program, which is described in one of the previous videos on my channel. You'll need to watch that first for this to make sense. What we're going to do is make some improvements to the original design, such as adding sort algorithms to the drop-down list automatically. We're going to add another sort algorithm in part 3 of the series, and we're going to move the sorting to a separate thread, which was probably the biggest problem in the original version. It all worked on the same thread, which is not good, so we're going to move it to a background thread. And finally, we are going to add a pause button. What's required? What do you need in order to do this? Well, first of all, watch the previous video. It'll be found on my same channel. You'll need to watch that first. It's about the same duration as this one, and it builds on the first phase of the project from the ground up. And you'll need a copy of Visual Studio, just like in the last version. That's about it. So how much coding is it? Not very much. We're just going to do 5 lines or so of adjustment to the interface. We're going to defer adding a new sort algorithm until part 3. We'll add a pause button. It's about the same size, 5 lines of code or so. We're going to populate the drop-down, 10 lines maybe, and then some other miscellaneous changes, maybe 25 lines of code or so not too bad. That's really all we're going to do today. Okay, so let's get right into the project. Okay, here we are in the iSortEngine interface. This is the first class that we're going to change. The first thing I'm going to do before even explaining what's going on is rename this to use an uppercase I. It's been bugging me since I wrote it. Okay, and as you can see, I've already renamed the file that goes with it. So we're going to need to change this interface around a little bit because we've changed the routines that sort engines are going to need to offer to their implementers. We're going to change this project from running in a single thread, thereby locking up the main form when it's running, to instead run on a background thread so that you can still use the controls on the main form while the sort engine is running. So in order to do that, we're going to get rid of this single do work method and we're going to replace it by 3 new ones. We're going to have a next step method, which every time it's called it will take 1 step towards sorting the output. And then we're going to need a test to know if we're done, is sorted. And finally, I've put in a redraw method so that you can pause and resume and refresh the graphics object if it is obscured for some reason, which is one of the problems with using a graphics object on certain Windows versions. So we'll be able to redraw it. Those are the only changes we need to make to the interface itself. So now we will update the bubble sort engine so that we can make and implement the new interface requirements. Okay, now let's go over to the bubble sort engine and make sure that it implements this interface the new way that we have it written. Alright, the first thing you see is that IntelliSense is complaining that the 3 new requirements of the interface are not being met. So we're going to take care of that problem. First thing, let's get rid of the system.threading.tasks because we don't need it. And we no longer need this sorted flag. We're going to create a constructor for this class. We're going to take these arguments that were originally in the do work method and we're going to put them in the constructor of this class. And then we're going to move these assignments out of do work and put them in the constructor. We can get rid of these here, and we're going to rename do work to next step. And this while not sorted loop, we can get rid of the loop. We can get rid of the reference to is sorted. And we can shift tab to move this over a little bit, clean up the block. And that will be our next step method. Swap stays the same, is sorted stays the same, I think, except that we're going to make it public so that it can be checked by the caller. And we're going to put the redraw that I was talking about earlier in here. I believe that's about all we need to do to this class. Yeah, I think so. Okay, so that's it for the changes we need to make to the sort engine. Now we'll move on to the main form and do the things that are required there. Okay, here we are in the main form of the application. Now we're going to make the changes necessary to support both selecting the sort algorithm from a drop-down list as well as running the sort on a separate thread. So we're going to start with running the sort on a separate thread. So first of all, let's get rid of the system.threading.tasks using statement. So we're going to need a couple of extra variables in the class here in order to keep track of the state of things. Actually, first we're going to need a background worker. This is the entity that's going to run the code of the sort algorithm on a different thread. And as you can see, that's in system.componentModel, which is already included here. That's why we didn't need to include the namespace. And also we're going to need a variable to keep track of whether the sort is currently paused. In the constructor of the form, we're going to need to do one more thing, which is to populate the drop-down list of available sort algorithms. So we're going to put that there. Now that method isn't written yet, so let's do a control dot and create the method and fill it in. First, we'll get rid of the not implemented exception, and we're going to ask the program to look through its own internal structure to find all the classes that implement the iSortEngine interface. So that looks like this. Okay, so this is a pretty good chunk of code for one line. So what is it? So what we're going to do is get a list of names of classes that implement the interface. So we're going to go through the current app domain and get the assemblies that are implementations of the iSortEngine interface. We're going to exclude the interface itself and also any abstract classes. We don't have any abstract classes right now, but it's there for completeness. And we're going to get the names of those candidates, cast them as a list, and put them in this variable class list. Then we're going to sort that list alphabetically, and then finally we're going to populate the drop-down list with the names of those. And for each of the entries in that list, we're going to add it to the drop-down. And now you remember on our main form, I'm talking about this drop-down list right here, which is actually a combo box. And then finally, we're going to set the combo box entry to the first entry in it. And then we're going to come down here to the bottom, and I'm going to move the button handler for the start button. I'm going to move that a little closer to the top because I'm going to use the bottom part of the file to put all the stuff that goes with the background worker. Okay, so I'm going to move that up here. These contents aren't any good anymore. We're going to forget about them. And we're going to create the new background worker instead, we're going to make sure that you can cancel the background worker's task. And then what we're going to do is we're going to add an event handler to the doWork event when it fires. That's why we have plus equals here instead of equals, because it's adding to a list of things that happens when the event fires. So we're going to be adding one. And it's going to be our implementation of doWork, which is not created yet, but we'll create that just as soon as we're done with this method. And then finally, we're going to run the background worker, and we're going to pass to it the value that is selected in the dropdown, which is to say the name of the sort engine that we would like to run. So down here at the bottom, I'm going to create a code region for the background worker stuff. And you terminate it by an end region directive. And within there, we're going to keep the background worker stuff. Now, a lot of people are going to object at this point. There's a common belief that a region is automatically a code smell. And it can be if it's used to hide pieces of code because there's too much to look at, your methods are too long, there are too many of them, and you hide them away in a region. That's a perfectly valid complaint, but I'm just using it here to group the background worker stuff together. You can feel free not to use it. As a matter of fact, the only thing we're going to have in here right now is the doWork method itself. Now you can see that we have two arguments here. If you've done a lot of Windows programming, you've seen this model quite a bit. There are two arguments to an event handler. The first one being the thing that raised the event, or the thing that caused this method to be invoked. And then the second thing is a block of arguments to it, which is customized based on what type of event handler it is. So the first thing that we're going to do is explicitly cast the sender here, which is to say the thing that caused the method to be invoked. We're going to explicitly identify it as a background worker, and then that'll make our code editing, for one thing, easier because IntelliSense will have the right context. And then we're going to extract the name of the sort engine that we wanted from the argument e.argument. Remember earlier when we set up our event, we passed an argument of the selected item in the combo box, which is the name of the algorithm. And we extract that here. So now we know the name of the sort engine we would like to run, and now we're going to figure out the actual type using reflection. We'll figure out the type of the concrete class that's going to implement the algorithm. So what we do here is prepend the namespace onto the sort engine name. So our namespace up here is sort visualizer. I've accidentally written sorting visualizer, which is wrong. So change it to sort visualizer dot, for example, bubble sort engine. So that will be the identifying of the class that we're going to create. And then we need to get the constructors of that type. In our sorting engines, let me pull up the bubble sort engine. We only have one constructor, which we modified a couple of minutes ago. And you'll recall that it took these three arguments, the integer array, the graphics object, and the maximum value of an entry in the array. So what we've done here back in the main form is examine the type and got a list of its constructors, so that at the end of this line of code there should be exactly one constructor. And for the next part, we're going to put in a try-catch block in case something goes wrong, so that the whole program doesn't blow up, and it will be able to catch the error here. What we're going to do is create a sort engine of the type identified and invoke its constructor. So let's break down what we're doing here. We're creating a sort engine, and remember that this is an interface name, iSortEngine, so it could be any one of a number of types as long as it implements the sort engine interface. And then we're going to invoke the first constructor in the list. There should only be one on the list. We're going to invoke, which is to say create an instance of that class, and we're going to pass to the constructor the list of 3 parameters that we need. So the array, the graphics object, and the maximum value, which you'll recall from earlier is the height of the panel. That's in the first video. Normally, you would probably expect to see the new keyword used to create an object, and it would look something like this. So that's how you would do it if you knew exactly which type, but since we're going to have more than one available type of sort engine, we can't do it that way because we would have to identify the concrete class here. So the way we've done it is to find the exact type based on the name and then figure out its constructors and then invoke the object with the first constructor. So those 3 lines of code are the general way to identify the class we're looking for when you don't actually know it. So that's how we do that. And we're going to actually run the sort, and that looks like this. Okay, so we're going to continue running while the list is not sorted, and the user has not clicked the cancel button. So while those 2 things are true, we're going to take one step towards sorting the list. So that's all we need here. And then the last thing we're going to need is what to do when the user pauses the program. So we're going to add a button. It's going to be the pause and resume button. So let's change the text. Pause and resume. I'll come up here and call it button pause. Double click on it to get an event handler, and here it is. Let's move that up towards the top of the file, right underneath the start button. So the user will click this button in order to pause the sorting or to resume it. When we enter here, there are going to be 2 possible states that we were in. Either we're not paused or we're paused and we're having to do 2 different things depending. So when the sort engine is currently running, what we're going to do is cancel it, or actually send a signal for it to cancel, and we're going to set our paused indicator to true. Otherwise, if we come in here and the program was already paused, then we're going to take the steps to resume the operation. We're going to remind ourselves how many entries there are in the list and their maximum value. We're going to mark our paused flag as false. And now we're going to fill in the display to automatically refresh the view. Okay, that's going to look like this. In case the display was disrupted in some way, this will refresh it before we go on. And then we're going to do like we did on the start button, which is to run the background worker. It's not actually resuming the background worker, but instead creating a new one, I'm pretty sure, because you can see it consuming more memory. But it's going to pick up where it left off in the sort, at least with the sort algorithms we have right now, which is to say only bubble at this time. But we're going to add another one in the next video, and it's going to also be interruptible and then be able to be resumed with a partially sorted list. Keep in mind, not all sort algorithms can do that, but the one we have now and the one we're going to add, you'll be able to restart on a partially sorted list and it'll pick up where it left off. Okay, so that's all we need to do to the form, and we have the pause and resume buttons. We already had our algorithm dropdown. We already had our start and reset buttons. So that is going to do it for part 2 of 3. There's one more video coming out about this project, and in it we'll do a little refactoring. We'll catch some exceptions that are possible. Also, we're going to add another sort algorithm and demonstrate switching between them even after the sorting has started. So thanks for watching, and I look forward to presenting part 3.